Welcome to this video session. Today, in this video, we will learn about pure and impure substance. Do you go to the market for shopping? If you look closely at the cartons of milk, ghee, juice, etc. that are being sold in the market today, you will find 100% pure or pure written on all the boxes. Can you tell us what is the meaning of pure? For ordinary people like you and me, if there is no adulteration in anything, then according to us, that thing is pure. But does the same thing mean pure things in the scientific definition? No. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance consists of single type of particles. So now you must be thinking, what are impure substances? The substances that are formed by mixing two or more pure ingredients are called impure substances. They are also called mixture. Let us now learn more about pure and impure substances by some examples. Let us take an example of salt. Is salt a pure substance? For this, we will first check whether salt is made up of the same type of particles. Here, you can see the particles of sodium chloride present in the salt. Are these particles identical? Yes. The composition of salt is composed of molecules similar to sodium chloride. Therefore, we can say that salt is a pure substance. Friends, we know that salt is made up of sodium chloride molecules. Can we separate salt into elements of sodium and chlorine by some physical process? No. Therefore, we can say that we cannot separate pure substances into other types of elements by any physical process. Can you think of examples of more pure substances? Yes, sugar, water, gold, diamond are examples of some more pure substances. Are the characteristics of 1 kilogram of sugar and 10 kilogram of sugar the same? Yes. From this, we can conclude that the characteristic properties of pure substances remain the same. Let us now look at the sugar and water solution. Is it a pure substance? Let us find the answer to this question by an activity. In a beaker, take this sugar and water solution and then heat it with the help of a burner. What do you see? Alright, sugar that was dissolved in water is separated from water due to evaporation. But can we separate sugars or water into their components by some physical process? No. From this activity, we can conclude that the solution of sugar and water is an impure substance or mixture, which consists of two pure substances, sugar and water. Can you think of more examples of impure substances? Potassium permanganate and water solution, tea, soil. These are some other examples of impure substances, which are made up of two or more pure ingredients. Friends, hope you have got a good understanding of pure and impure substances. In the next video, we will learn about the mixture and types of mixture. video session. In the previous video, we studied about pure and impure substances. In this video, we will study about mixture and types of mixtures. We all feel very happy to take a walk on the beach, isn't it? Let us do an experiment with seawater. Let us take a little seawater in a beaker and heat it with the help of a burner. What do you see? Absolutely right. Sodium chloride dissolved in seawater is separated from water due to evaporation. Therefore, we can say that seawater consists of sodium chloride and water. However, sodium chloride is itself a substance and cannot be separated by physical process into its chemical constituents. Substances like seawater, which consist of more than one pure elements or compounds, are called mixture. Friends, are mixtures only liquids? Think. Since pure elements, solid, liquid, or gaseous, can be found in any of these states, mixtures can also be found in any of these conditions. For example, air is a mixture because it is made by mixing different types of pure substances and compounds, such as oxygen, carbon dioxide, etc. Friends, seawater and air are both blends. But are their characteristic properties the same? Of course not. This is because they are made by mixing different ingredients. Different types of mixtures are formed according to the nature of the component. Let us now discuss the types of mixtures. We will learn about it through an experiment. Gather 3 of your friends for this experiment. Now, take 50 ml of water in 4 beakers. Suppose we name these 4 beakers as A, B, C and D. Now dissolve 1 teaspoon of sugar in A beaker. Tell your friend to dissolve 3 teaspoons of sugar in the B beaker. Now ask your second friend to dissolve 1 teaspoon of oil in the beaker C, and finally ask the third friend to dissolve 1 teaspoon of sodium chloride and iron filings in the beaker D. Notice the texture of all the blends. Let us first look at the mixtures of beaker A and beaker B. What do you observe? Are A and B blends of the same texture? Correct. The types of mixtures in which the components mixed are uniformly distributed throughout the mixture is called homogeneous mixture or solutions. Mixtures A and B are both homogeneous mixtures made from the same component. But if we look at the intensity of the sweetness of the beaker A and B mixtures, we will find that they are different. As a result, we can see that homogeneous mixtures can have different composition. Now look at the mixtures of beaker C and D. Are these blends of the same texture? The components of mixtures obtained in C and D beakers is different physically. The mixtures which contain physically distinct parts and have non-uniform compositions are called heterogeneous mixtures. Can you think of examples of some more heterogeneous mixtures? copper sulfate and potassium permanganate and water, salt and sulfur and water. These are a few examples of heterogeneous mixtures. Friends, in this video, we studied mixture and types of mixtures. In the next video, we will study what are the solutions, suspensions, and colloids. In the previous video, we learned about the mixture and the types of mixtures. In this video, we will learn about solutions, suspensions, and colloids. Let us first know what is a solution. Do you like to drink lemon water? Lemon water is an example of a solution that consists of sugar and salt particles and water particles. And because it has the same texture, it is a homogeneous mixture. From this example, we can say that solution is a homogeneous mixture of two or more substances. Are the solutions only in the form of liquid? No. We can also have solid solutions such as alloys and gaseous solutions such as air. But what makes these solutions? We can divide any solution into two parts, solvent and solute. The component of a solution whose volume is greater than the other and which dissolves the other component in it is called a solvent. The component of a solution which is usually in small quantity and dissolved in the solvent is called a solute. Let us understand this by an example. Do you know the solution of iodine and alcohol, which we call tincture of iodine? We make a solution of tincture of iodine by dissolving iodine in alcohol. Because here we take iodine, which is in small amount, and alcohol, which is in large amount, to make a solution. In this solution, iodine is solute and alcohol is solvent. Aerated drinks are also a solution in which carbon dioxide is dissolved in water. Therefore, carbon dioxide is solute and water is the solvent in aerated beverage solution. Now, let us study the properties of solutions. We will try to understand it through an activity. Take a tincture of iodine solution in a 50 ml beaker. Is the texture of tincture of iodine the same? Yes. Therefore, we can say that the solutions are homogeneous mixtures. Can you see tincture of iodine particles? No. Why? Because the diameter of particles of the solution are smaller than 1 nanometer. Therefore, they cannot be seen with the naked eyes. If we try to cross the beam of light in this beaker with the help of a torch, what do you see? Yes, you can see that the path of light is not visible in the solution. This happens because the particles of the solution do not scatter a beam of light passing through it due to their small size. Try separating iodine from this tincture of iodine solution using a filter paper. Did you succeed? No. Therefore, we can say that the particles of solute cannot be separated from the solution by the method of filtration. And if we keep this solution undisturbed, then you can see solute iodine particles do not settle down. That means solution is stable. Friends, you are aware that the solution contains different amounts of solvent and solute. Depending on the amount of solute present in the solution, it can be called diluted, concentrated, or saturated solution. Let us know about it through an activity. Take 50 ml of water in 2 separate beakers. Mix salt in one beaker and sugar in another and mix them well. Keep the salt and sugar dissolved in both of these beakers until you cannot dissolve any more salt or sugar in the solution. Are the amounts of salt and sugars dissolved in water equal on this temperature? No. At any given temperature, the solute may dissolve as much as the capacity of solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. The amount of solute present in a saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. Now, if we heat these two saturated solutions on 5 degrees more and then try to dissolve them in salt and sugar, what do you see? We can see that we are able to dissolve more solute in solution. By this activity, we can conclude that at a given temperature, the solubility of different substances is different. The amount of solute dissolved in a given mass or volume of solution is called concentration of solution. We can write it in this way. We can also write the concentration of the solution in a percentage in these ways. Friends, if 50 grams of sugar is solute in 200 grams of solvent water in a solution, can you calculate the concentration of the solution? Pause the video and think about the answer, and then match your answer. We can solve this question in this way. Friends, now that we have learned about the solution, let us now learn about suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. For example, take 50 ml of water in a beaker and dissolve 1 teaspoon of chalk powder with the help of a glass rod. What do you see? This solution is a heterogeneous mixture in which the solute does not dissolve but remains suspended throughout, and we can see these suspended particles with our eyes. Through this activity, we can see the properties of suspension. 1. Suspension is a heterogeneous mixture. 2. Suspension particles can be seen with the naked eyes. Now, if we cross a beam of light with the help of a torch in this suspension, we will find that these suspended particles scatter the beam of light, making its path visible. Solute particles settle down when left undisturbed. That is, suspension is unstable. Now, finally, if we filter this suspension with the help of a filter paper, we can easily separate the chalk powder from water. Therefore, we can say that suspended particles can be separated from the mixture. Let us now take the last type of solution, that is, learn about colloidal solution. Take water in a 50 ml beaker. Now, add few drops of milk to it. What do you see? Milk particles are spread evenly in water. Can you see the milk particles? No. But if we try to pass a light beam from this solution with the help of a torch, we will find that the milk particles easily scatter a beam of light. Therefore, this solution looks like a homogeneous mixture, but in reality, this solution is a heterogeneous mixture. Such solutions are called colloidal solutions. Let us now look at the properties of colloidal solutions. By this activity, we can conclude that 1. Colloidal solutions are heterogeneous mixtures. 2. Colloid particles are so small in size that they cannot be seen separately by the naked eye. 3. They are so large that they scatter a beam of light and make its path visible. 4. When they are left undisturbed, then these particles do not settle down at the bottom. That is, they are quite stable. If we filter this colloidal solution with filter paper, can we separate milk and water? No. Therefore, we can say that colloids cannot be separated from the mixture by filtration. And friends, do you know another interesting thing? The dispersed particle which remains in colloidal form is called dispersed phase. And the component in which the dispersed phase is suspended is called dispersing medium. Colloidal is classified according to the state of dispersing medium and the dispersed phase. Here, you can see some examples of this. So friends, hope that you now have a good understanding of solution, suspension and colloid. In the next video, we will study about separation of components of mixture. Welcome to this video. In the previous video, we studied about solutions, suspensions and colloids. In this video, we will study the separation of components of mixtures. As we know, most of the substances around us are found in the form of mixtures. A variety of methods are used to separate the components of these mixtures. But you may be wondering, why is it required to separate the components from the mixture? Separation makes it easy to obtain and use information about each component of the mixture. The heterogeneous mixture can be separated by simple physical processes such as selecting by hand, filtering and sieving, etc. But can we separate all the mixtures by physical processes? For example, can we separate ink into its components by some physical process? No. special techniques are used to separate mixtures such as ink. Let us now study some of these techniques. First of all, we will learn about evaporation. Let's try to understand it through an activity. Fill half the beaker with water. Now, place the watch glass on the face of the beaker and put some drops of ink on the watch glass. Now, start heating the beaker. What do you see? We can see that evaporation is happening from the watch glass. We will continue heating the beaker until it evaporates. After a while, you will see that there is no change in the watch glass. Then we will stop heating it. Is there any residue left on the watch glass? Yes. We can see that the blue component, dye, appears as a residue on the watch glass. So, according to you, which substance has evaporated from the watch glass? Absolutely correct. Water? So we can now conclude by this activity that ink is a mixture composed of water and color components, in which water is a solvent and color is a solute. And we can separate the solute from the solvent in mixtures such as ink by evaporation. Let us now learn about the second technique of separation, centrifuge. Take milk with a little bit of whole cream in a vessel. Now, try to separate the cream from milk by filtering it with a sieve. Did you succeed in it? No. Why so? In fact, the particles of cream present in milk are so small that they come out of the filter container. Then, how can we separate mixtures such as milk with cream? Now, let us take this creamy milk in a test tube. Now centrifuge it for 2 minutes with a centrifuge machine. What do you see? When the centrifugal device is rotated rapidly, heavy milk particles settle down and light cream particles remain on top. Particles of creamy milk, blood, wastewater, etc. are too small that it cannot be separated by filtration, but can be separated by centrifugation. Now let us learn about the technique of separation of a mixture of insoluble liquids. In this activity, we will put a mixture of kerosene and water in a separation funnel. Now, we'll leave it undisturbed for a while. What do you see after a while? Yes, after some time, separate layers of water and oil are formed. But why so? This is possible because water and kerosene are insoluble liquids. Kerosene, being lighter than water, rises upwards to form a separate layer. And due to the water being heavy, it remains in the bottom layer. Now, we can open the stopcock of separation funnel carefully and remove the bottom water layer into a beaker. Close the stopcock as soon as the oil reaches the bottom. In this way, we can see that the liquids which are not soluble among themselves can separate into different layers according to their density. Therefore, with the help of the separation funnel, mixtures of insoluble liquids such as water and oil, molten iron and slag, etc. can be separated. Let us now learn about the next technique, sublimation. Take a mixture of salt and ammonium chloride in a ceramic cup. Now cover this cup with a funnel upside down and close the open end of the funnel with cotton. Now, heat the ceramic cup slowly using a burner. What do you see? As the cup is heated, the vapor of ammonium chloride rises upwards from the cup, and after some time, this vapor starts to settle on the cool surface of the funnel. Keep the ceramic cup warm until the vapor stops coming out of it. Now, turn off the burner and scratch out the solid ammonium chloride in a bowl. In this way, we separated the mixture of salt and ammonium chloride. But how was this possible? This was possible because ammonium chloride is sublimable substance that converts directly from the solid state to the gaseous state upon heating. By this activity, we can conclude that to separate such mixtures that contain a sublimable volatile component from a non-sublimable impurity such as camphor, naphthalene and anthracene, the sublimation process is used. The next separation technique is chromatography. Let us understand this by an activity. Take a thin layer of filter paper. Draw a line with a pencil 3 centimeters above its bottom edge. Now, place a drop of water-soluble ink in the center of the line with the help of a sketch pen. Allow this drop to dry. Now, take some water in a jar and keep this filter paper in such a way that it stays just above the surface of water. Now leave it undisturbed. What do you see? Different colors are seen on the filter paper. How did this happen? Why did this happen? As the water moves upwards on the filter paper, it also takes the dye particles along with it. Often the dye is a mixture of 2 or more colors. The color component, which is more soluble in water, rises faster, and thus the separation of colors becomes possible. This method of separating components from a mixture is called chromatography. It is a method used to separate solutes that dissolve in the same type of solvent. For example, in separating pigments from natural dyes, separating drugs from blood, etc. The next separation technique is distillation. Let us try to understand it through an activity. Take a mixture of acetone and water in a distillation flask. Put a thermometer in it. Now, arrange the device in this way. Heat the mixture slowly and carefully observe the thermometer. As the mixture heats up, what do you observe? Vapor distillation of acetone appears to rise in the flask at approximately 56 degrees Celsius. This acetone vapor passes through condensation, it starts condensing and again accumulates in the beaker in the liquid phase. In this way, we can separate the mixture of acetone and water by distillation. This was possible because a mixture of acetone and water is a mixture of 2 miscible liquids that boiled without decomposition and have sufficient difference in their boiling points in between 56 degrees Celsius and 100 degrees Celsius. To separate a mixture of 2 or more miscible liquids for which the difference in boiling points is less than 25 K, fractional distillation process is used. You may be thinking that by fractional distillation method, we can only separate the mixture of liquids. But can we use the distillation method even if we have to separate the gaseous mixture? Let us know about this by the example of air. Air is a homogeneous mixture and its components can be separated by fractional distillation. Suppose we have to separate oxygen gas from air. To do this, first let us arrange the devices in this way. We have to separate the other gases present in the air to get oxygen from the air. To obtain liquid air, the pressure on the air is first increased and then air is cooled by decreasing temperature. This liquefied gas is slowly heated in the fractional distillation column, where all the gases separate at different heights according to their boiling points. Now, finally, the last separation technique is crystallization. Take about 5 grams of impure copper sulfate in a ceramic cup. Dissolve it in minimum amount of water. Filter out impurities. Now vaporize the water with a solution of copper sulfate to obtain the saturated solution. Cover the solution with a filter paper and leave it undisturbed at room temperature to cool throughout the day. What do you see? We can see that there are crystals of copper sulfate in the ceramic cup. This process is called crystallization. Now you might be thinking that which mixtures can we use to separate by using this process? We can use crystallization to purify salt. For example, when receiving salt from seawater, it may contain many impurities. The crystallization method is used to remove these impurities. Crystallization is the method by which pure solids in the form of crystals are separated from the solution. And do you know, the crystallization method is preferable over a simple evaporation method for the following reasons. 1. Some solids disintegrate or some scorch when heated, like sugar. 2. Even after filtration, some impurities can remain in the solution if the impurities are dissolved in the solvent. These impurities can contaminate the solid when evaporated. Thus, according to the nature of the mixture, we can get pure substance by using any of the methods we have learned. Friends, today we studied separation of components of mixtures. Video. In the previous video, we studied about the separation of mixtures. In this video, we will study the types of pure substances. So far, we have studied substances and mixtures. But do you know that we can classify substances according to their chemical composition into elements or compounds? Let us first learn about elements. Do you know Robert Boyle was the first scientist in the world who first used the word element in the year 1661. Antoine Laurent Lavoisier, 1743 to 94, a French chemist, was the first to establish an experimentally useful definition of an element. According to him, element is the basic form of matter that cannot be divided into other simple substances by chemical reaction. Elements can generally be classified into metals, non-metals, and metalloids. Let us first learn about some properties of metals. 1. They have a luster, shine. 2. Their color is silvery grey or golden yellow. 3. They are conductors of heat and electricity. 4. They are ductile and can be drawn into wires. 5. They are malleable and can be hammered into thin sheets. 6. They are sonorous, make a ringing sound when hit. Now you may be thinking, what can be the examples of a metal with so many properties? Gold, silver, copper, iron, sodium, potassium, etc. are examples of metals. And do you know an interesting thing? Mercury is a metal that remains liquid at room temperature. Let us now look at some properties of non-metals. 1. They display a variety of colors. 2. They are poor conductors of heat and electricity. 3. Unlike metals, these are non-lustrous except iodine. 4. They are not sonorous. 5. They are not malleable. Can you think of some examples of these? Examples of non-metals are hydrogen, oxygen, carbon, bromine, etc. And finally, metalloids are substances whose properties resemble both metal and solid non-metals. They are lustrous like metals. They are semiconductors of electricity. They are not tensile or malleable. Boron, silicon, germanium, etc. are examples of metalloids. Friends, do you know what we get when two or more elements combine? Let us understand this by an activity. Take 50 grams of iron powder and 3 grams of sulfur in 2 separate ceramic cups. Now mix iron powder and sulfur powder in the first bowl, and in the second bowl, mix iron powder and sulfur powder. Heat the mixture until it becomes red at high heat. Now remove the flame and allow the mixture to cool. Are the materials obtained in both cups similar in appearance? The gas obtained in a cup 1 is hydrogen. It is colorless, odorless and flammable. While the gas obtained in cup 2 is hydrogen sulfide. It is colorless gas and smells like rotten eggs. Now check the magnetic properties in both cups. Bring a magnet near the material. Check if the material is attracted to the magnet. What do you see? The material obtained in cup 1 has magnetic properties, while the material obtained in cup 2 does not have magnetic properties. Although initially the given substances were similar, the materials obtained in both the cups showed different properties. Why did this happen? This happened because the action done in cup 1 resulted in the physical change of the substances, while the action in the cup 2 resulted in chemical changes in the substances. Material obtained in the cup 1 are 2 substances, a mixture of iron and sulfur. the properties of the mixture are similar to those two elements. The material obtained in cup 2 is a compound whose properties are completely different compared to combining elements. In this table, you can see the difference between a mixture and a compound. Friends, today we have studied the types of pure substances.